Hey, geometry students, Mr. Zacek back and better than ever. Here we are, Geometry, Unit 1, Lesson 10. We're talking about partitioning a segment into a given ratio. What I want you to think about with this is I want you to think about if you're running a 5-mile race. And in that 5-mile race, if you had run 2 miles, well, you had gone 2 miles and you have 3 miles remaining. So of the 5-mile race, we could break it down into 5 parts, and you have 3 left. There's a 2 to 3 ratio. That will be a kind of an illustration we'll take a look at here in a minute. So follow along as I'm going to read through here. A directed line segment is a line segment that has a direction associated with it by moving from one endpoint to another. For example, given directed line segment AB, it is implied that the direction is from point A to point B. The first point listed is the start of the directed line segment, and the second point listed is the end of that directed line segment. So this here, A, the first point listed should be thought of as having coordinates x sub 1, y sub 1, and the second point should be thought of as having x sub 2, y sub 2. So what I'm saying here is the direction of the line segment is it's going from A towards B, and that direction is going to matter. Now, in addition to the direction, we have components. The components of a directed line segment describe the direction and length of a directed line segment. The components describe the route from the starting endpoint to the ending endpoint. So the x component is how the x value is going to change, and the y component is how the y value is going to change. So x sub 2 minus x sub 1, y sub 2 minus y sub 1, that should look familiar for us from the distance formula. Though that's what we do, x2 minus x1, y2 minus y1. The components of the above can be described. Notice this little notation, we use these arrows around, and x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. So that's how the x value is changing and how the y value is changing. So we're going to look at an example here. Find the given points. A is 4, 3, B is 19, 8. Find the coordinates of point P on a directed line segment AB that partitions AB into a ratio of 2 to 3. So look at the ratio given. The ratio is 2 to 3. We can write it with a colon, or you can write it as a fraction. All of those are different ways of writing a ratio. And in order to divide the segment into the ratio of 2 to 3, think of dividing it or partitioning it into 2 plus 3 or 5 congruent parts. So this is the example that I was sharing about running a 5-mile race. You know, you start here and we're at mile 2, but we have to get to mile 5. So we've gone, this would be 2, oh, I want a pen, hang on. So this would be 2 parts, and this would be 3 parts, equal parts. So therefore point P is 2/5 of the way from the first endpoint to the second endpoint. So here's how we're going to go about doing this. So that first part is like, okay, here's how we can think about this problem. Now step 2 and step 3 are going to be actually how do we calculate it. So the first thing we're going to do is find the components. That's the change in x and the change in y. So we label our starting point A as x1, y1, and our endpoint B is x2, y2. And we got our little formula here, x2 minus x1, comma, y2 minus y1. So we take 19 minus 4 and 8 minus 3. So that means our x value is changing 15 units and our y value is changing 5. So from 4 to 19 is plus 15, and from 3 to 8 it's plus 5. That's what those numbers represent. So now here's what we do. Begin with the starting x coordinate, which is 4. Add 2/5 of the x component to find the coordinates of P. So your starting point is 4. We're going to add 2/5 of 15, and we get 10. That's the x coordinate of P. And then we repeat that process. Begin with the starting y coordinate and add 2/5 of the y component to find the y coordinate of P. And that's 3 plus 2/5 of 5. Remember, how much did the y value change? Let me just use the highlighters here to help you see. So we had used yellow. The x component was 15. The y component was 5. All right, and that comes out to be 5. So P is located at 10, 5. All right, now this summary, this is a formula that you can use for the whole thing. We're not really going to focus on this formula so much. We're just going to kind of do it out, do the different pieces of it out, but it's the starting x point plus the fraction of the component. All right, that's really what this whole formula says. Let's do some practice here. Okay, 2 examples. All right, the first one. Given points A are 2, 4, and B is 8, 10. Now we could draw this on a coordinate plane, but I'm just going to draw it out here on a line, and I'm going to say that A is here. Whoops. Give me a pen. So A is 2, 4, and B is 8, 10. So we want our starting point to be x sub 1, y sub 1, and x sub 2, y sub 2. Okay, so let's figure out first, how is the x changing? So x2 minus x1, which is what? 10 minus 2 equals 8. That's our x component. Let me get a different color here. We'll do the y's. So now we've got y2 minus y1. So that would be, oh, I didn't do the right one for x. Somebody here, you probably have already been shouting at me, saying, Mr. Zacek, you didn't do the right one, and you are correct. That should have been 8 minus 2, which is 6. And now for our y component, that should be 10 minus 4, which is also 6. So both the x value is changing by 6 and the y value is changing by 6. So now what we're going to do is we're going to take from the starting point 2, 4. So let's do the x1 first. So we do 2, and we're going to add. Now here's where the ratio comes in. So a ratio of 5 to 1. So 5 to 1 means that there's a total of 6 parts to this. So we're going to do 5, 6 of the x component, which is this 6 down here. So 5, 6 of 6. So if you have a calculator, you can put this in, but really what this is going to come out to be is 2 plus 5, which is 7. See, the 6's divide out when you do that out. That's going to be our x coordinate for P. And then down here we're going to do the y coordinate. So we start with our starting y coordinate. That's 4 over here. We use the same fraction, plus 5, 6. The component in this case also is 6. And so that is going to come out to be 2 plus 5. Or, excuse me, keep making these little errors. That's going to come out to be 4 plus 5, which is 11. So point P, and we need to put parentheses around it, is going to be the point 7, comma 11. Okay, let's do one more example here. Hopefully I'll be a little cleaner in my presentation. Okay, so in this one, what do we got going on here? We've got point A. Oh, we got some negative values. We've got to be mindful of those. So A is the point negative 5, 4, and B is the point 7, negative 4. So we're going to label my first one x1, y1, x2, y2. So that's a 1. All right, find the coordinates of P on the directed line segment that partitions AB into a ratio of 1 to 3. So I'm going to start off by finding the components. And remember, that's x2 minus x1. So that would be 7 minus negative 5. Whenever that second number is a negative, you want to put it in parentheses. So that means 12. And if we think about that, if we're going from negative 5 to 7, that means we've gone up 12. Now for the y components, so we're going to do y2 minus y1, which would be negative 4 minus 4, and that means negative 8. So that means we're going down 8. So we go from 4 to negative 4, and that's down 8. So we found our components. If we wanted to put them in that component form, we'd write it as 12, negative 8. Whoops, not a parentheses, just a little arrow thing. Okay, so now we got to deal with this 1 to 3. Well, 1 plus 3 is 4, so that's going to be the denominator of our fraction. And we have to make sure that we pick our starting point. So let's do the x first. So it's going to be negative 5 plus 1/4. And the 1 comes from this one right here. That's our numerator. The 4 comes from adding these two together. So negative 5 plus 1/4 of our x component, which is 12. So that's going to be negative 5, 1/4 of 12 is 3. Negative 5 plus 3 is negative 2. And then we do our starting y value, which is 4. Same fraction, plus 1/4. Our y component is negative 8. So it's 4 plus 1/4 of negative 8 is negative 2. 4 plus negative 2 is 2. So point P then is going to be the point negative 2, comma 2. And that divides that segment into a ratio of 1 to 3. Okay, we've got a few assignments related to this that are going to help you get lots of practice. This shows up a lot. It's been on every kind of geometry exam. So we're going to do it a number of times on problem sets. You're going to want to keep this one handy and really do your best to master this early. Right now it looks like a whole lot, but as you get doing it, things will start to roll. Okay, good luck. Thanks.